Good morning, everybody. How are you? Hope all of you are well. And today I will continue your chapter, that is language of chemistry. And from this chapter, today we will discuss radicals and chemical formula. Okay, today we will learn how to write the chemical formula. So before that, first we have to discuss elaborately about radicals. Now most of the inorganic compounds, okay, or salts contain two oppositely charged particles, and these are called radicals. The positive charged particles are called cations and negative charged particles are called anions. That positive charged radicals are also called basic radicals or electrophile radicals, and the negative that is the anion, negative charged particles, anions, are called acid radical, or they are also called electronegative radicals. If you think about magnesium oxide, calcium oxide, aluminum chloride, potassium iodide, here the first, okay, the symbol, that is the magnesium, is the symbol of basic radical Mg2+, and next one is the acid radical O2- in case of magnesium oxide. In case of calcium chloride, Ca2+ is the basic radical and Cl- is the acid radical. Okay, so in this way you have to write the formula by using this basic radical first and then acid radical. The writing of chemical formula we will discuss after this. First we have to discuss the radicals. Okay. Radicals also may be a simple radical or a compound radical. A simple radical contains only one atom. A compound radical contains more than one atoms. Like Na+, Cl-, O2-, H2-, these are simple radicals containing one atom. But SO4-2-, NO3-, PO4-3-, CO3-2-, these are called compound radical because it contains more than one atoms. Thus, a radical is an atom or a group of atoms that carries positive and there may be negative charge and acts as a single unit in a chemical reaction. A radical is represented by its formula and its charge is written at the right side top. Okay, and here in case of radical it may be acid radical or basic radical. Okay, so what is the valency? Valency is equal to the charge of the radical. Suppose we can give you one example, aluminium 3+. So here charge is 3+, as well as its valency is what? Valency is 3. Now one by one radicals we will discuss. Like monovalent radicals. Monovalent basic radical. So here you have to know the name of the radical as well as symbol with their charge, then you will be able to know the valency. Like sodium plus, okay, so its valency is what? 1. This is sodium. Okay, next one is K plus, potassium, then ammonium. Okay, any type of alkali metal all are positively charged. You can think about the transition metal also. Transition metal we can tell about that Cu plus, Au plus, Ag plus. Okay, these are transition metal. And one non-metal basic radical is also present, that is called NH4 plus. Okay, H plus. H plus actually exists as hydronium ion. Okay, cesium plus. And next one is divalent basic radical. Divalent basic radicals. So definitely here valency will be 2 as well as charge will be 2. You can think about the alkaline earth metal like calcium, magnesium, beryllium, strontium. So you can write beryllium 2+, magnesium 2+, calcium 2+, strontium 2+, So these are divalent basic radical. You can think about the transition metal also, like zinc 2 plus, Fe2 plus, zinc 2 plus, Fe2 plus is called ferrous, Cu2 plus, that is called cupric. Okay, then nickel 2 plus, magnesium 2 plus, already discussed, Mn2 plus, manganese 2 plus. So these are the divalent basic radical. Next, trivalent basic radical, we can write that aluminum 3 plus, trivalent basic radicals. Okay, in trivalent basic radical we can write aluminum 3 plus, chromium 3 plus. Okay, we can write bismuth also 3 plus, antimony 3 plus, arsenic 3 plus. Okay, one chart is given that you have to keep in your mind. Okay, if you practice regularly, then you can easily able to remember this thing. Without knowing this thing, you cannot able to write the formula. Next, we will tell you tetravalent basic radical, that is Pt4 plus, tin, that is tannic, Sn4 plus, pambas is plus 2, lead plus 2 and pambic is plus 4, Pb plus, silicon plus 4. So these are tetravalent basic radical. And pentavalent basic radicals are also present, like As5 plus, Sb5 plus, that is arsenic antimony pentavalent. Okay. Next we will discuss about the monovalent acid radicals. Monovalent acid radical. Here we can tell you about that halogen, that fluoride, chloride, bromide, iodide, all are monovalent. F minus, Cl minus, Br minus, I minus, hydroxide, these are all monovalent acid radicals. Or we can go to the compound radical like ClO minus, hypochlorite, hypobromide, like this. We can think about that nitrate, nitrite. This is nitrate and this one is nitrite. They are also monovalent acid radical. Perchlorate, ClO4 minus, this is also monovalent acid radical. Bisulfide, HS minus, this is also monovalent acid radical. Okay, and iodide, IO3 minus. Okay, these are all monovalent acid radical. Next we will discuss divalent acid radical. Divalent acid radicals. Next, divalent acid radical, we can tell that carbonate, CO3 2 minus, sulfate, SO4 2 minus, sulfide, SO3 2 minus. Okay, we can think about that more complex type of compound like zincate, ZnO2 2 minus. Okay, we can think about that oxide, that is the oxide sulfide. These are the simple radical. Okay, here also they are divalent. Understand? Next we can tell you that chromate and dichromate. These are also CrO4 2 minus and Cr2O7 2 minus. So these are also what? Divalent acid radicals. Okay. Next there is trivalent acid radical like aluminate AlO3 3 minus, nitride N3 minus, phosphate PO4 3 minus, phosphide P3 minus, and then we can tell borate BO3 3 minus. Okay, so this thing you have to keep in mind. Next one we will discuss the tetravalent acid radical, tetravalent carbide C4 minus. Okay, and ferrocyanide, that is FeCnl whole 6 4 minus. When we are thinking about the ferricyanide, this is valency is this is a trivalent aciditical. Here valency is 3, FeCnl whole 6 3 minus, and ferro is FeCnl whole 6 4 minus. Okay. And many radicals are given and many are still not in your book. Okay. One book is available in market, that is the language of chemistry. Okay. I think it will be written by author name I forget. Maybe Kollani Publications. Okay. So that book also may be helpful. Okay, to get the details about the formula, or you can get the chart from internet. But in your exam, whatever is given in your book, only from book will come. Your book is your syllabus. Okay, so whatever radical is given in your book, that is for your exam purpose. If you want to know more, then you have to study the book of language of chemistry. Okay, here only one chapter is there in your book, that is the language of chemistry. I am telling about one book. The name of the book is language of chemistry. Okay, you will search in internet, you will get. Next, we will discuss about the chemical formula. Now, what is the formula? The formula is formula of a substance is the symbolic representation of a chemical substance. Okay, like sodium chloride. What it is represent? This is rock salt, or you can tell common salt, or you can tell that table salt. Okay, so when we are writing NaCl, it is indicating that this is sodium chloride. Okay, sodium chloride is the chemical name, and chemical formula is the NaCl. Now, radicals are charged particles, but a compound as a whole is electrically neutral. Okay, so the total charge of acid radical is equal to the total charge of the base radical in a particular compound. Suppose AlCl3, aluminum trichloride, Al3 plus is there, and that will be neutralized by 3Cl minus. Okay, so here total positive charge and total negative charge is equal, and that is why AlCl3 is neutral molecule. Okay, although it exists as dimer, okay, that is different thing. Acid radicals, okay, actually the source is the acid. You can think about any acid radical like Cl minus, it is coming from the hydrochloric acid. Hydrochloric acid can supply you Cl minus. And basic radical like Na plus, base is the source here. So Na plus will be supplied by NaOH, sodium hydroxide solution. Okay, so if you mix these two, NaCl and HCl, there will be formation of reaction of acid and base, neutralization reaction, formation of salt and water. So it will form NaCl. Okay, now Na is plus coming from our base, and Cl minus is coming from that acid. Okay, hope you can understand what I am telling. And next, we will discuss how to write the formula of a compound. You have to know the symbol and valency of both acid radical as well as basic radical properly. Without knowing the formula writing in chemistry subject, you cannot study the subject properly. Okay, so chemistry by means. Okay, what is the meaning of chemistry? That is, there is discussion of 118 elements, their compounds, their formula. Okay, so formula is very much important. Chemistry means there is chemical reaction. So when you want to write chemical reaction or balanced chemical reaction, you have to write the proper formula. Otherwise, your chemical equation will be incorrect. So if you try to remember the radicals and their formula, then the handling of this writing formula will be very much easy. Okay, so what you can do, you can make one chart, okay, and paste it on the wall. That means radicals you have to write in chart also given in your book. That chart you have to write in sketch pen. You make it colorful so that you can easily understand. Okay, you can easily remember these things. Okay, so if you practice regularly, then it will be very much easier, and your chemistry also will be study of chemistry subject will be very much easier. Okay, so formula writing is very much important. Solely you can remember all the formula, and if you work hard on it. Hope you can understand. Next we will start the writing of chemical formula. The method today we shall discuss is called Criss-cross method. Criss-cross cross method. Okay. Now you have to follow some steps. Your first step is the writing the symbol of basic radical and acid radical, okay, side by side. First you write basic radical is written first, then acid radical. Next, step 2, in case of more than one compound radical, it should be kept in a first bracket or parenthesis, okay, in a particular compound. Next, step 3, write the valency of each atom as top of its symbol, okay, and you should ignore the plus sign or minus signs. From acid radical you are getting that minus charge and minus sign, and in basic radical you are getting that plus charge. In compound there should not be any plus charge, minus charge, okay. Actually compound is neutral, so you have to ignore it. Next, divide the valency numbers by their highest common factor, that is HCl, if any, to get the simplest ratio, okay. Next step, okay, so interchange of the valencies of the radicals, that you have to do. And next and the last step in the writing formula is the write the interchange valency numbers to the lower right of the radicals, and if the radical is a group of atoms and has a valency number more than 1, then enclose it within parenthesis, okay. If I give you one example, then you can easily understand, okay. Suppose if I give you that the example of aluminium sulfate, then how to write the formula? First you have to know the symbol of aluminium, that will write, okay, and what is the valency of aluminium? So here aluminium is present as +3, and sulfate, side by side we are writing that sulfate is 2-. So aluminium valency we are writing at the bottom 3 and sulfate is 2. So then Criss method, aluminium will take this valency of sulfate and sulfate will take this the valency of aluminium. So finally you will get Al2 as single atom. We are not giving any bracket, but this is a compound radical, 3 sulfate is there. So you have to write Al4, Al2, SO4 whole thrice. So that will be the formula of aluminium sulfate. Next, there is confusion. Many students are asking about the aluminate and meta-aluminate. Okay. Now I am writing the formula of sodium meta-aluminate. Okay. Now first you have to write the symbol of sodium. So what is the symbol of sodium? Na plus, last one. Its valence is 1. Here I am writing 1. Next one is the meta-aluminate, AlO2 minus. So this is also 1. So when both are 1, we should not write anything. By Criss method we are applying. So that will be NaAlO2. So here you should not write Na1, AlO2 1. You need not to write. When only one radical is present, you just write the symbol NaAlO2. This is the formula of sodium meta-aluminate. Now sodium aluminate. So here sodium is +1 and aluminate is AlO3 -3. So here 1 and here 3. So its formula will be Na3AlO3. Here AlO3 we are not giving any bracket because only one compound radical is present. If there is more than one compound radical, definitely we have to give bracket. But here also we are not writing Na in bracket because Na is the symbol of only one atom. That is why we are writing Na3. So in this way you have to practice the formula. Next I am giving a very important formula like aluminium nitride. Aluminium nitride. So in this case aluminium is +3 and nitride is 3-. So here both the valencies are 3. So definitely we have to take the ratio. You have to divide it by 3. So its formula is not Al3N3. Okay, if you write this one Al3N3, this is wrong. This is not the formula. So here you have to write Aln. Like magnesium oxide, magnesium 2 plus and oxygen 2 minus, both valency is 2. You should not write it that Mg2O2. So here you have to divide it, okay, by the common factor, that is 2. Okay, if you take the ratio, this is not the correct formula. You have to write MgO, magnesium oxide. In the same way, if you want to write the formula of ferric sulfate, iron is in plus 3 state and sulfate is 2 minus. Okay, so valency of iron in ferric is 3 and valency of sulfate is 2. So its formula will be Fe2SO4 whole thrice. In the same way, ammonium acetate. Okay, so here generally it is written that you can write that NH4CH3CO. Okay, I am writing here ammonium acetate. So ammonium is NH4 plus and acetate is CH3COO minus. So both having the valency 1. So you can write this one NH4 CH3COO, but generally it is written at CH3COO NH4. Okay. So here one thing you have to keep in mind, that this ammonia is a basic radical but do not contain any metal. Okay, this is non-metal basic radical. Okay, a compound radical. Okay, but all basic radicals, okay, except NH4 plus and H plus are metal atoms. Okay. So today up to this, okay, and you have to practice formula, and next day we will discuss about the balancing of a chemical reaction. Okay, so thank you everybody.